Okay, everyone. So we're starting the next unit. So Unit 4 is all about solutions and chemistry involving with different solutions. So this first lesson is an introduction to the types of solutions you're going to come across and essentially kind of definitions of, what are the different components of a solution and what a solution is to begin with. So it's just a little introduction lesson here. Okay, so first of all, when we have the term solution is a homogeneous mixture of two or more substances. So when we say the term homogeneous mixture, so first of all, a mixture means you have at least two different particles that are there, so two different substances. So a very simple one could be salt and water, right? So salt is dissolved in water. So you still have two substances, right? Salt and then water, but they're now just mixed together, right? So when you're looking at it, it appears as if it is one phase. So you don't have variable, you're not going to have proportions that are not fixed. So what that means is, for example, let's look at this tea, this cup of tea here. It's not like you have it's not like you have a clump of tea at the bottom and then the rest of this is pure water. Everything is completely dissolved. It appears to be one phase. So when you're looking at it, you can't even really tell it's a mixture right away, just on appearance alone. So just by comparison, if you remember the term heterogeneous mixture, so you learned these way back, probably even in elementary school, but a heterogeneous mixture is where you have at least two or more phases. So this could be like oil and water, let's say. So they're not mixed. You can see the separation. So homogeneous mixtures are always referred to when we say solution. A solution is a homogeneous mixture. So actually this is interchangeable with the term solution. As soon as we say the word solution, it automatically means it is a homogeneous mixture. So what makes up a solution? So there's two parts to every solution. Doesn't matter what type we're talking about, there's always two components. We have a solvent and we have a solute. Okay, and when the two come together, they make a solution. So let's talk about what this is. So the solvent is the substance that you are dissolving the thing into, So solvent is usually what you have in the largest quantities or the largest amounts. Solute is the substance that you are trying to dissolve. So for example, if I was making a solution of salt water, right, my solvent would be water, right? That's the thing let's say I have a glass of water and my solute would be salt. I'm trying to dissolve this into the solvent. So the solute is always being dissolved into the solvent. Now the solute can come in a whole bunch of different states, solid, liquid, or gas. And actually the solvent can also be different states, solid, liquid, or gas. It really depends on what type of solution we're trying to make. So in this case, if I'm doing salt in water, my salt, of course, is a solid, and my water in this case is a liquid. So this is like the classic. Usually when you think of the term solution, that's kind of what we always think about. Something that's solid dissolving into something that's liquid. Okay, but there's a whole bunch of different things that can classify as being a solution, and we'll talk about them in a bit. Okay. All right, so you're going to see these terms come up time and time again actually in this unit. So when we say the term concentration, okay, concentration is referring to essentially how much solute we have in the solution, okay? The more concentrated something is, the more of a solute that they have in that particular solution. So for example, we have two kind of generic terms here. So we have the term concentrated and the term dilute. Okay, so Dilute basically means that there is a small amount of solute. A concentrated solution means we have a high amount of solute. So if you look at the picture down here, this is kind of a nice way of looking at this. So this is an example of food coloring that is dissolved in water. So actually the food coloring is a liquid. So this is a liquid dissolved in a liquid. So you'll notice that the more concentrated, you can tell obviously it's red food coloring. So the more concentrated the solution is, the more drops of food coloring that was added. So this one on the far right has the highest amount of food coloring. So this would be called the most concentrated. It has the most solute. As you go further and further to the left, you can see here it's a very, very pale pink. This has a very small amount of solute. So this is the lowest concentration of solute, or we can say it is the most dilute. Okay, so the term dilute, actually, sometimes maybe you've heard of this term before. Sometimes it's also referred to as like it's a watered down solution. So let's say, you have maybe you added too much sugar into your tea and it tastes too sweet. One thing you can do to try and make it taste less sweet is to dilute it. So what you would do is you would add in more water. So the less concentrated something is, the more dilute it is. Obviously, the more solute you add, the more concentrated it is. So this one here, the light pink one, would be the most dilute or the least concentrated. And as we go to the right, we have the most concentrated. Okay. But it's always in reference. Notice we're always talking about it in terms of the solute. Right? We're talking about how much solute we have. Okay, so let's look at the different types of solutions that we can come across. Okay, so different types of solutions. So notice we always have a solute and we have a solvent. So remember the term when we say something is aqueous. So if I have an aqueous solution, that means that the solvent is always water, right? That literally means dissolved in water, okay? But you can have a whole bunch of different other types of solutions. So for example, you can have a gas dissolved in a gas. So for example, air. Air is 80% nitrogen. So your solvent is actually nitrogen because it's the biggest component in air. Then you have a whole bunch of other gases in there, right? So we have oxygen and water vapor and carbon dioxide, right? There's a whole bunch of other gases that are mixed in with the nitrogen in air. So air is a really nice example of something we don't normally think about, but it is a solution. It's a homogeneous mixture. We can have a gas dissolved in a liquid. So for example, a carbonated or bubbly soft drink, right? So when you open up a can of pop, there are bubbles that are inside of that liquid, right? So originally how they got that there is they dissolved the gas, which is a carbon dioxide, into the liquid portion, which is the pop part, right? The liquid part. Liquid mixed with a liquid, so alcohol in water. Also, you can think of this as, let's say you have, I'm trying to think of a liquid that you guys would know. Let's say you have, juice that's concentrated, like a concentrated strong juice, and you add in more water, so it's like a watery juice. I don't know, maybe people don't do that anymore, but or coffee and milk. How about that? Or tea and milk. So you have liquids and liquids that are mixing with each other. Okay. Solid dissolved in a liquid. There's a whole bunch of examples, but salt water is kind of the one we always think about. Or we can have a solid dissolved in a solid. So this happens a lot with metal mixtures. So an alloy is a mixture of different metals. So for example, you can have copper and nickel that are mixed. You can have steel that has iron and mixed in with a whole bunch of other different compounds. You can have brass. Brass is a type of mixture. So you can have a solid dissolved in a solid. Okay, so the one we always tend to think about, though, of course, is this one right here. Right here. So solid dissolved in liquid. Now, be honest, this is the one that we're going to use the most often when we're talking about solutions because it's the one that we make in chemistry the most often. Very rare, you're doing a chemical reaction where you're dealing with gases. Okay, typically you have a solid and you dissolve it. Okay, so here's some more examples, just talking about, and these are from a textbook, looking at different types of solutions. So here we have a solid dissolved in a solid. So here we have steel. So steel has carbon dissolved in iron, and actually there's a whole bunch of other different metals in there too. But iron is actually this solvent. I don't know why my mouse is doing that, but iron is actually the solvent in this case. Even though it's a solid, it seems weird to say. Solid dissolved in a liquid. So here we have salt and a whole bunch of other things dissolved in water. So for example, water from the ocean or seawater has a whole bunch of different dissolved things in it, right? It's actually definitely not safe to drink. A solid dissolved in a gas. So this is actually a rare one. Okay, so this is an interesting type of solution where we have a solid dissolved in a gas. So this is where you have actually sublimation happening, or essentially it's a reaction essentially happening between a solid and air. So it's not technically sublimation, I take that back. But mothballs, actually, very few compounds are able to do this. So mothballs are essentially a compound that when it essentially is in contact with air, it forms a solution. So what happens is the mothball scent gets mixed in with air. So that's why it's very pungent odor. If you've ever seen them, or I should say, smelled a mothball, you'll know exactly what I mean. So those are often added to clothes or things that are put in closets. So to keep away different organisms and different bugs, but mostly moths, which is kind of where it gets its nickname from. Okay, so liquid dissolved in a solid. So this is where you would put, for example, a liquid toluene in wax to make sure the wax is able to apply. So this happens a lot. Maybe if you helped your parents or somebody that you know who does a lot of like woodworking. So it's used quite a bit to make sure you have a seal on top of usually furniture or let's say wooden stairs. It's used quite often, but it's a liquid, a liquid toluene that's actually used for the solid wax. So the wax is actually the solvent in that case. Okay, liquid dissolved in liquid. Antifreeze is an example of that. So this is where you have liquid. Usually it's a mixture of ammonia and other molecules that's in liquid form that's mixed with water. And liquid dissolved in gas, it's a nice one when you look at water vapor in the air, humidity in the air. So water essentially has dissolved in the air. So you then have particles that are causing humidity that are essentially suspended in air. Okay. Gas dissolved in a solid. Interesting enough, air is often trapped inside of ice. So even ice cubes that are inside of your freezer have trapped particles of air between them, between the space. Gas dissolved in liquid, we already talked about a carbonated beverage, and gas dissolved in gas. An example here is methane gas that's mixed with ethane and nitrogen, carbon dioxide, and other gases. So the gas that comes out of, let's say, your stove, if you have a gas-powered stove, this is not pure methane. So methane is actually the solvent. There are other gases that are mixed within it that essentially allow it to work efficiently in your house when you're cooking.